Hello there, you are welcome to today's class. In today's class, we'll be dealing with prime factors. But before we dive into today's class, you need to understand the meaning of some words like factors. What are factors? Factors are whole numbers that divide another whole number without any remainder. Factors are whole number that divide another whole number without any remainder. For example, if you are asked as a JSS1 student that what are the factors of 12? That is 12. What they're asking is that what are the numbers that you mention? Write out the numbers that will divide 12 without any remainder. For example, 1. 1 is a factor of 12 because 1 will divide 12 without any remainder. 2. 2 is a factor of 12 because 2 will divide 12 without any remainder. 3. 3 is a factor of 12 because 3 will divide 12 without any remainder. 4. 4 is a factor of 12 because 4 will divide 12 without any remainder. 6. 6 is a factor of 12 because 6 will divide 12 without any remainder. But if you try 5, 5 is not a factor of 12 because 5 will divide 12 in 2 times and you have remainder 2. So factors are numbers that will divide another number without any remainder. So before we go through prime factors, what are prime numbers? What are prime numbers? Prime numbers are numbers that have 2 factors, 1 and a self. Prime numbers are numbers that have 2 factors, 1 and a self. So that will lead us to the definition of prime factors. What are prime factors? Prime factors are factors that are factors of a number that are prime numbers. Prime factors are factors that are prime in nature. So today we'll be looking at how we can solve for prime factors of a number. And solving for prime factors of a number, you can make use of 3 methods. You can make use of multiplication method, you can make use of division method, you can make use of family tree method. As for this class, we'll be making use of only multiplication method. If you are interested in learning both division method and family tree, for division method, you can watch the video up here. You can find it on my channel. And for family tree method, you can watch this video. You can also see it on the channel. So let's solve some questions using multiplication method. Let's assume that you are asked to find the prime factors of 180. So the first step is that you think of 2 numbers that if you multiply it to each other, it will give you 180. For example, 18 times 10 will give you 180. 18 times 10 will give you 180. But the problem with this is that both 18 and 10, they are not what? They are not prime factors. So what are you going to do? You think of a number that if you multiply with each other will give you 18. That is, you think of a 2 number that the product of the 2 numbers will give you 18. 3 times 6 is what? 3 times 6 is 18, right? 3 times 6 is 18. Then you think of 2 numbers that if you multiply it together, it will give you 10. 2 times 5 will give you 10. Now, if you look at the figures that we have here, 3 is a prime number, 2 is a prime number, 5 is a prime number, but this 6 is not a prime number. So you also have to think about 2 numbers that if you multiply it together, it will give you 6. Now, this 3, you maintain the 3. Then you think of 2 numbers that if you multiply with each other, it will give you 6. 2 times 3 will give you 6 times 2 times 5. So these are the what? These are the product of prime factors for 580. It is possible for you to express this in what? In index form. And index form is just a short way of representing a number that has been multiplied, that has multiplied itself in repeated ways. For example, now if you look at 2 now, I'm going to represent it in index form. How many 2 do we have? That would be 2. That would be 2 raised to power 2. What 2 raised to power 2 means is that 2 times 2. That's what 2 raised to power 2 means. Now if you look at 3, 1. How many 3 do we have? That's 1, 2. So that would be 3 raised to power 2. And we have only 5 left. So this is the what? The product of prime factors. These are the product of prime factors for 180. What if you are asked to deal with a bigger number? Let's say, okay, let us clean this place. Let's clean this part. Let's assume that you are asked to find the product of prime factors of 900 using multiplication method. It's as simple as ABC. The first step is that you think of 2 numbers that if you multiply with each other, it will give you 900. 90 times 10 will give us 900. 90 times 10 will give us 900. But both 90 and 10, they are not what? They are not prime numbers. They are not prime factors. So what do? You move further by thinking about 2 numbers that if you multiply with each other, it will give you 90. There. If you multiply 9 times 10, 9 times 10 will give you what? 90. You move on. You think about two numbers that if you multiply it together, it will give you 10. 2 times 5 will give us 10. Now, if you look at 10 now, 2 and 5 are both what? They are both prime numbers. They are both prime numbers. But if you look at 9 and 10, they are not what? They are not prime numbers. So you have to move further by thinking, by asking yourself that which two numbers do I have to multiply with a set that will give me 9? Now, 9, 3 times 3 will give you 9. And what about 10? 2 times 5, what? Will give you 10. And you still maintain this 2 times 5. Now, this product of prime factors, you can express it in index forms by starting from the what? From 2 now. We're going to start from 2. How many 2 do we have here? 1, 2. That will be 2 raised to power 2. And how many 3 do we have here? 1, 2. That will be 3 raised to power 2. And how many 5 do we have here? That's 2. So, this is the what? This is the final answer. This is the product of the prime factors of 900. And the last, let's deal with a bigger number. And this is the last question for today's class. Let's assume that you are asked to find the prime factors, the product of prime factors of 1, 5, 1, 2. Now, you have to think of two numbers that if you multiply together, it will give you 1, 5, 1, 2. If you look at the terminal number here, which is 2, you will know that if you divide this number with 2, it will surely be doable. And look at it now. I'm just going to do a rough work on this side. 151 divided by 2. 2 1 is not possible. 2 15, that will be 7. Remainder 1. 2 11, that will be 5. Remainder 1. 2 12, that's 756. 2 times 756. 2 times 756 will give you 1512. So you move on. You still repeat these two. Then you think of two numbers that if you multiply it together, it will give you 756. Well, you can still divide this 756 with a number that you know that it will divide it. 2 should be able to divide it because of this 6, which is the terminal number. 2 can divide it. 2 in 7 is what? That will be 3. Remainder 1. 2 times 3 is 6. If you take 6 out of 7, you have 1 left. 2 in 15, that will be 7. Remainder 1. And 2 in 16, that will be 8. That is 2 times 3 7 8 will give you 7 5. That will be 2 times 3 7 8. 2 times 3 7 8. Consider 3 7 8 is still a big number. So you keep looking for two numbers that if you multiply together, it will give you 3 7. That will be 2 times 2. So we get to 3 7 8 now. Which two number will give us 3 7 8? Which two numbers that if you multiply with each other will give us 3 7 8? If you don't know, you can just divide the 3 7 8 by a factor that can divide the terminal number, which is 8. So I believe 2 can divide it. 2 in 3 is what? That will be 1. Remainder 1. 2 in 17. That will be what? 8. 2 times 8 is 16. If you take 16 out of 17, you have 1. And 2 in 18, that will be 9. So 2 times 189 will give you 378. That will be 2 times 189. So let's move on. You will still repeat these 2. Then which two number, the product, which two number that if you multiply with each other will give you 189. Now, if you look at what name 189, you look at the terminal number to guess which number you can use to divide it. I believe that 3 will be a perfect factor to divide it, or perfect number to divide it. 3 in 18 is what? That will be 6. 3 in 9, that will be 3. That's 3 times 63. 3 times 63 will be 189. We are not yet there because we only saw when all the numbers are prime factors. So 2 times 2 times 2 times 3 and 63. I think you can think of a number that if you multiply two numbers that if you multiply with each other, it will give you 63. 7 times 9 is 63. So we still move on because 9 is not a what? It's not a prime factor. It's not a prime number. You move on. That will be 2 times 2 times 2 times 3 times 7. Then you think of two numbers that if you multiply with each other to break this 9 down, you think of two numbers that's 3 times 3. So this is a what? Is a product of prime factors for 1512. But we can still express this product in index form. We are going to start with 2. So how many 2 do we have here? We have 1, 2, 3. That will be 2 raised to power 3. Then how many 3 do we have here? We have 1, 2, 3. That will be 3 raised to power 3 times 7. So the product of prime factors for 1512 is 2 raised to power 3 times 3 raised to power 3 times 7. So this is how to solve for prime factors of a given number using multiplication method. So if you are here to subscribe to my channel, Mr. Willis Math channel, kindly hit the subscribe button and put on your notification button, and I will be expecting your comment about today's class. God bless you.